Okay. All right. Hello, everyone. Thank you for joining us for today's session. My name is Wayne Gakor. I lead the Angular Kenya community. Happy to see all of you here. Thank you for joining us for this session once again. And today's session is going to be about just learning about all these new features that Angular came with, especially from Angular v16, where it kicked off what you call the Angular Renaissance. That is new features that were meant to improve the developer experience and even make it easier for beginners to get started with Angular. I'm not going to spoil too much of it. We have Lance today again on stage, who's going to introduce himself, and also he's going to get into the thick of it. And yeah, hope that you get to enjoy. And in case you have any question, please feel free to share it on the chat. All right, Lance, over to you.
All right, thank you. Thank you, Wayne. Hello again. I was here a couple weeks ago talking about promises and observables and signals, and there's going to be a lot of signals in this talk, but it's coming at it from a different direction. Here are the slides. Don't worry, I'll have this, or a QR code for the slides, and don't worry, I'll have a QR code on the last slide as well, so you can get it there if you want to. But I'll get started. This will be talking about the Angular Renaissance, some key new features, as Wayne said. And some of these features aren't that new anymore, but if you're coming from an older version of Angular, I know there are people still working on Angular 12 and 14, these will be new for you. But then there's also some stuff that's brand new, even with the very last minor release of Angular. So again, I'm Lance Finney. I'm from the United States. I work for a company called Inficon, and I'm a Google developer expert in Angular. So let's get started. So a brief history of Angular. I'm going to start with that because Renaissance means rebirth, a restart of something. And so it's kind of useful to know why something had to be reborn. So Angular JS was created in 2010, and it was a huge deal at the time. It was one of the very first major single-page application frameworks, and it was definitely the best of the breed for a while and got a lot of attention. Google brought it in-house, and it was really popular. But unfortunately, there were some core architectural problems that the core Angular team recognized, and they wanted to fix them. And the approach that they took was to start from scratch. And they created Angular, originally called Angular 2, now just called Angular. And it's not just that it dropped the JS. It's not just that they updated the logo a bit. It truly was a whole new framework. And it was a much better framework than Angular JS. But unfortunately, there was no migration path. It was a brand new framework. And so a lot of the people in the community decided, well, if I have to start over from scratch, maybe I'll check out React or Vue or Svelte or whatever instead. And so the community did lose some membership as people did not like the need to rewrite things. But those of us like me who stuck around were rewarded, as I said, with a much better framework than we had before. But unfortunately, even though it was much better, it still had some architectural problems. There were things that the renderer and the compiler just couldn't do that they wanted. And so they decided to rewrite it again. But they learned their lesson. Instead of rewriting it from scratch, they rewrote it as we were using it. They did something called Project Ivy. And with Project Ivy, they rewrote the renderer and the compiler as we were all using it. It's kind of like changing an airplane's engine out while it's in the air. It's a very impressive technical accomplishment. The downside of it was that for a couple of years, they were really focused internally. And we as developers didn't get a whole lot of new features and a whole lot of innovation. But they promised us that Project Ivy, by rewriting things, would give us that new set of features, the new innovation. Unfortunately, that promise turned out to be true. And we really saw this about the time that Angular 17 came out a couple of years ago. there was a lot that changed. So much that they decided to give it a whole new website, a new logo, and a lot of people organically, not even the Angular core team, but outside of the core team, referred to it as the Angular Renaissance, because there was so much innovation that people who had been making fun of Angular for a while were now really excited about it. And people on Twitter and other social media were saying, hey, what's going on? This is kind of cool. What's Angular doing now? And it was a rebirth. So this happened around Angular 17. It's still going on. The most recent minor release was Angular 21.2, which came out in February. Angular 22 is going to come out in May. So I'm going to be talking about 4 major areas that came out in this Renaissance. And I figure if we're talking about a Renaissance, it might be useful to bring in some people who know about the Renaissance. So I'm bringing in Leonardo, Michelangelo, Donatello, and Raphael. They're going to help us out. So the first of these is standalone components. Raphael is going to help us with this. So what is this? Standalone components means that we no longer have to attach our components to other files. Angular was weird when it first came out in that a component was not the solitary smallest unit of compilation. That's how it is for other frameworks, which all use components. But with Angular, the component didn't live by itself. In order to have a component, you had to register it with this other file, a module. And you had to have, and the module is the place where you defined your dependencies and a lot of your metadata about your component. And it was just kind of weird that you'd be working on your component by itself, but then that component had to have part of its definition in a completely separate place. But now components are essentially their own modules. All of the stuff that used to have to be in another file is now in the component itself, which gives us a simpler mental model and some advantages that I'll show later. So here's an example of a component that Raphael worked on that got converted. On the left, we see this component. It's a simple component that models their sewer hideout. And I'm going to talk about it a little bit because we'll use this example throughout the session. All this has, it has one bit of state, whether the manhole is open. And if that manhole is open, then we show a welcome message. If the manhole is closed, we don't show it at all. And then there's a button. The button will say either close manhole or open manhole, depending upon what the current state is. And when you click it, it'll open or close the manhole. So not a lot going on, but just a little component with some behavior. And as we see on the left, this is the old version. And the way we can tell, this is the old version. Not much had to change when we went to the new version, but a little bit did. When we went standalone, we added this line to say it's standalone true. Now, we don't actually need this anymore. That was necessary in versions 17 and 18 of Angular. As of 19, standalone true is the default, so we don't even need it anymore. But I'm showing it just so that you can see it as it's explicit. The line below it is the important one, though, because this is where we have a change that didn't get updated, and this is where the component takes care of itself now. In the old component, it used the welcome component, and it used the ngIf. We also use them now, but you notice there was nowhere in the old component where we defined those dependencies. Now we define those dependencies. The component says, all right, I control everything, so I know what I depend on, and I depend on these two things, and so I'm explicit about it. So what we end up with is another line or two of code that we didn't have previously. And often, generally in programming, we think it's better to remove code. So is it good that we had to add a line of code? And the answer is yes, because adding this one line lets us get rid of entire files elsewhere, and it's a gain. So let's take a look at the file that we had before. We had the module, the ng module, the Angular module, that is the place that registered our component. And the important part of it is what we see on the bottom, this ng module decorator. It declared that that sewer component belonged to the module. It also declared that the welcome component belonged to the module, which meant because both of those components lived in the same module, the sewer component could use it. In the old way, we'd have to create that relationship in the module file. In the new way, that relationship is set up directly in the component itself. The other part of it was that ngIf, where that came from, we used to import the common module. Common module gave Angular a whole bunch of stuff that came from Angular but wasn't part of the default implementation. So you had to specify that it was there. ngIf is part of that, but only one small part of it. So in order to get ngIf, we imported the whole common module so that all of the components within this, the sewer component and the welcome component, could use it. So again, this common module, which is a big thing, was replaced by part of that one line in the new way. And the other part that used to be in this module is routing. At the top, we're setting up a route that when we route to this module, we actually show the sewer component. And that's done through the imports line of router module for child, setting up those routes. And I showed you where the other parts of this decorator went. But where does that routing go? Turns out we don't need it at all. And we can understand that better if we look at the core files for Angular. The true core files for an Angular application is the main.ts. Main.ts is where we set up everything and where things go from there. And we had a main.ts before, and we have a main.ts now, but they're a little bit different. In both cases, we have the way that we bootstrap our application. The old way on the left, we would call platform browser dynamic and then bootstrap a specific module. And you can see with the highlighted code on the bottom, once we bootstrap that module, we bootstrap the app component that it belongs to. So there's a two-step bootstrapping from main.ts to the module to the component we need. Well, now we use a different API. We say bootstrap application and we specify the component. So we go directly from main.ts to the component. We skipped this middle intermediary that just didn't add anything. And the other part of this here is our routing. We're set up so that when we go to /sewer, it would route to, in the past, the sewer module, which then we saw on the previous page. Once we route to the sewer module, it routes us to the component. The new way on the right, we see, instead of loading the children, which goes to a module, we load the component, which goes directly to the module. So again, we previously had to do from the root to a module to our component. Now we go directly from root to the component. And that's why that whole section, that previous file, isn't necessary anymore. We just don't do two jumps. We do a single jump. We don't need that information anymore. It wasn't adding anything. And the APIs are a little bit different. Instead of load children, it's load component. Instead of router module for root, it's now provide router. And in fact, things like this are where the true complexity and difficulty come in, and the true power when we're going to standalone components. The components themselves don't change much. We really just add that one import line. But setting up our application overall to not use modules and to use the new provider approaches that are component-based, that's where most of the work will actually be if you make this conversion. And this actually fulfills the original intention for Angular. When they created Angular 2, this is what they wanted. And in the alphas and the betas and the early release candidates, we had something like this. But unfortunately, after one of the release candidates came out, they realized that there was a corner case with some dynamic components that they just couldn't handle with the approach that they had. The renderer and compiler just wouldn't do it. So at the last minute, they had to add our modules as this intermediary. And no one ever liked it. It was this extra thing, but now we don't need it anymore. Project Ivy enabled the renderer to do what Angular wasn't able to do before. And so now we have the original vision fulfilled. The status of this is it was introduced in Angular 14 and 15. It was by default for new components in 17, and it's truly default and implicit now as of 19. And there are migration schematics to help you convert your old components to the new components. As I said, they'll do a lot of the good work for the components for you. You'll have to do more of the work in your bootstrapping, in your main.ts and associated files, but it does a lot of the work for you. Now Leonardo is going to help us with the next step, the new control flow syntax. And here we're going to look at a component that's pretty much the same as what we saw before, but there's a little bit extra. As before, if the manhole open property is true, we'll see a warning. And there's a button that allows us to hide and close, or close and open the manhole. But we have something else here. We have an else. If that manhole isn't open, we're going to say stay out. We're going to be mean to people because we don't want them to come into our clubhouse. And this works. We have in our TMNT welcome component an ng if manhole and an else closed. And then the way that we do our else is that because we say the word closed, there has to be somewhere in the file. It doesn't have to be directly below. It could be anywhere. A hash closed on an ng template, and then that template is included in there. And this works, but it's weird. It's the only if construct I've ever seen where the if handling is inside the thing that's being controlled. And it's also weird that we have this, we have the hash concept, we have the ng template concept. What if we had else ifs? Well, what we would have to do is inside this closed ng template, we would have to have another ng if, and then another ng template somewhere with a hash, and who knows where it is in the file. So we could have these kind of go-tos that are anywhere, and there's a lot of code around having to do all this. We have a new way of doing if that's so much cleaner. If manhole open, welcome. Else, stay out. We're done. Now, we're not entirely done. We have to do an @ sign in front of the if and the else, so it's a little bit weird, but not that bad. And it's so much less weird than it was before. Anyone who knows anything from a C-based programming language could look at this and know, oh, if else, I know what's happening. That wasn't true with the old way. The old way you had to learn. This way, you pretty much just understand. Additionally, if we had else, well, we would just, or else ifs, we would do @ else if block, @ else if block, @ else if block. There's an easy construct there. We don't have to duplicate these weird things. It's handled for us. And also notice, we don't need to import anything anymore for this. We still need to import the welcome component, but we no longer need to import ng if. Ng if wasn't always there, so we needed to explicitly say it. The new control flow syntax is built into Angular. It's just part of the Angular syntax, so we don't even need to specify it. So overall, yeah, it's much better. There's a little bit of weirdness still with that @, but that's so much less weird than it was before. And Angular isn't really that different than its competitors these days. Like, Svelte will put a hash and then a colon else, and Vue will be a v dot, and React has a slightly different way. They all do things to say, all right, this is not something HTML really can handle, so here's our special escape syntax. Angular uses the @, but it's basically the same as its competitors now. The next one to look at is a for loop. Here we're going to look at a list of pizzas, because the turtles love their pizza. We're going to have an unordered list, so a bulleted list, and we'll have one bullet, an li, for each pizza in the pizzas array, grabbing the index out as I, and then we'll say like 1 sausage, 2 pepperoni, 3 cheese, whatever it is, by I plus 1, taking our 0 base to making it 1 based, and so we can have that in there. And if it turns out there are no pizzas, we'll say bummer, because we can do an ng if, check the pizza length, and say bummer, because it is a bummer not to have our pizza. That was the way that it worked before, and it did work, but again, it was weird. We have our ng4 inside the thing being looped. Where else do you see that? Nowhere. Look at the new way. It's a for loop. If you know JavaScript, you know this. @for, so it still has the @, but for every pizza of pizzas. Okay, track is kind of weird. I'll come back to that. But for every pizza of pizzas, then inside that we have our bulleted list, and we show what we need. We can just grab our index, it's $index. You can also do $sign first, $sign last, $sign even, $sign odd. But $sign index plus 1, pizza.name. And then optionally, when there's nothing in there, we can do @empty, and we'll see our bummer. We don't even need to do an if. it makes a lot more sense. It's a lot more readable. So what is this track thing? So track is an important performance issue for us in certain circumstances. Imagine instead of what we see here, we had a pizza list with 50 pizzas on it that was sorted alphabetically. And the users could change the name of their pizza. So they could change, say, sausage to Italian sausage. And because it's sorted, as they change it, it's going to jump up, 17 positions in the list or whatever. Well, without any sort of tracking, what would have to happen is Angular would say, all right, there's been a change made. I have 50 elements in this list. I don't actually know what changed. I don't know what they were. I'll just re-render everything. With track, we can say, all right, we have 50 items. This one here, it's moving. And it is just it is moving and renaming. You have to really re-render that one because it's a whole new thing to show. But all the rest, you have their ID. They haven't changed. Their ID hasn't changed. What you display about them hasn't changed. You don't have to do any work except just move them. So re-render the one thing and put it in the new spot and move everything else around. That's a much smaller operation for the browser than re-rendering all 50 of them. So we can get a big performance boost out of this. And in order to do that, we say track on something that is unique for every element in there. So the ID is going to be unique, so we can track on our ID, and we're done. In this case, since nothing changes in there, I could actually just track on $index, and that would be fine. But if we actually had something more complicated and we were allowing the user to move things, we should give it an actual unique ID there. And we actually could do this before. With the star ng4, there was a tracking mechanism, but it was weird. So almost no one ever did it. And the algorithm wasn't as fast. But now it's faster in a simpler syntax, so they made it required. So if you don't really need anything, as I said, you can just do track $index, and that'll be easy. But otherwise, track on something that's actually in there. And now we have our for loop, and it's simpler. We don't have to import our ngIf. We don't have to import the ng4, and it's really readable, and it's great. The last part of it is switch. And switch, again, worked, but again, was weird. All right, so we're going to switch on the color. So when we get the color purple, we want to show the Donatello component. And we get blue, we want to show the Leonardo component, on. And if we don't match anything, we'll show Splinter. Okay? But then it had to be a little bit weird. We had to wrap everything in an ng container, which was there only because we had this structural directive. And then to define what we're switching on, we have to use square braces for that. But all the structural directives within it use stars. So you have to remember, okay, is this the square brackets or is this the star one? Which one is it? And you have the switch case and the switch default and the switch. It worked, but it was kind of weird. The new way, switch on your color. Case purple, Donatello. Case blue, Leonardo. Case orange, Michelangelo. Case red, Raphael. Default, Splinter. We're done. It's just easy. Now, and we also don't need to import these things. We don't have to remember these things. Sure, it's a few more lines of code, but I'd rather have more lines of code that are explicit and readable than what we had before. Plus, we've gained type safety. Color is now known to be a string because of what it happens to be in this component. So if we tried to do a case of 5, that would be a compile time error, not just a runtime error. In the old way, it was runtime only, but now it's compile time. So that's good for us. So again, just simpler to read, simpler to reason about, and more powerful. So overall, the advantage is fewer imports because these things are just built in, which means smaller bundles. Better performance, especially with the ng4 tracking, better type safety, especially with switch, easier ergonomics, and there's easy migration with schematics. It works like 99% of the time. This came out initially in developer preview in 17. It's stable in 18. And the old ways are deprecated. Maybe they'll be removed in May, maybe later. I'm not sure. And now Donatello is going to help us with the next one, deferrable views. And deferrable views are different than the first two topics I talked about, because the first two are, there's a better way of doing something that we could do before. Deferrable views are actually a new thing. It improves our user experience by giving us lazily loaded views. Now, we've had lazy loading for a while, for a long time, but it was always lazy loading at the route level. Like when we go to this page, the entire page will be lazily loaded. But what if we wanted to do something where, all right, at the very bottom of this page, after we scroll down, there's a component that is pretty heavy. So we don't want it to come in unless the user actually needs it, scrolls to it or clicks on something. You couldn't really do that before. There were some ways around it to do it, but they were very difficult and almost no one did them. So essentially, we didn't have that capability. Well, now we do. Now any individual component, any individual line can be lazily loaded, which is much finer detailed lazy loading than we had before. And this works with standalone components. Standalone components are what allow us to be lazily loaded. So what does it look like? This is the basic syntax. And there's a lot of optional syntax here that we don't always have to use, but I'm showing everything. It also came at the same time as the control flow, so that's where these @ signs come from. It's the same basic idea. The minimal part we need is @defer, and then a block, and then the things that you want to lazily load. So let's just focus on that part for now. What we'll say is we are going to defer this until some trigger happens. On idle is the default. We can explicitly put it here. We'll see in a moment what the other triggers are. But until that trigger happens, the things inside the defer block are not on the screen. And more importantly, anything in that block that is a standalone component hasn't even been pulled from the server yet. So in this case, app idle is an old style component, and app idle is a standalone component, and app non-standalone is an old style component. Both would be hidden on the screen until the trigger happens, but only the standalone component, the app idle, will be truly lazily loaded. And I'll show that in a moment. So again, everything within that defer will be hidden until some trigger happens, and then they will be displayed, and anything of that that's a standalone component will be fetched for the first time at that point. So on idle means it'll wait until everything else on the screen is done loading, and then when the browser has a moment to catch its breath, go grab that. So things that you have aren't going to be visible until the trigger. Do we want to put something there as a placeholder? Yes, we do, and that's what @placeholder as an option gives us. So the placeholder is what will be displayed until the trigger is executed. And in this case, I'm going to optionally say that it's going to show for a minimum of 2 seconds. So even if the on idle is really quick, we'll still show this placeholder for 2 seconds. And the reason we want to do that is otherwise we might have something that just flashes at our users, and that kind of annoys them because they don't know what they missed. So we put something up there, show it for at least 2 seconds so they have a chance to see it. It gives a better perception, even if the performance isn't better. And then sometimes loading takes a while. So we might want to show a different placeholder while the loading is happening if it's a particularly large component. And that's @loading, which we again show for the optional minimum of 1 second. So it'll show the placeholder first. And then when the trigger happens, it'll start loading, and it will show the loading. And when the loading is done, it will show what's in the defer block. And that with the potential of a minimum of 2 seconds, and there are other options there. And if there's some error that happens while we're loading it, we can show that as a final placeholder. And there's 6 built-in triggers for loading and prefetching, and you can create your own. And I'm going to jump over to a live app to show these. So this is a step that is from the curriculum for Angular Bootcamp, which is a company I used to work for. I created this step, and so I'm going to show you what I created as a demonstration of this. So here we have this part here is always there, and this part down here is in a defer block. And I'm going to reload. For 2 seconds, we see the placeholder, and then we see our actual content. 2 seconds, the placeholder, then our content. And the important thing you might notice is over here on our network tab, the idle component, that standalone component, came in after and separately from everything else. Now, this is a tiny toy application, so we can't really see how long It takes for something to go idle, so it's not a great example. So I'll prove it more by going to a viewport, one of the different triggers. And what this will do is give us that power that I hinted at earlier of what if we want something only to be loaded in when the user scrolls it into view. Well, I have a list here, scrollable list, and if I keep scrolling down at the bottom, there we have this. The last element in this scroll list is wrapped in a defer viewport. So we don't even load it in from the server until we've scrolled down and put it into view. We have interaction. So I can click on this text to load it. If you look over here, we don't have any, we only have viewport. Now I click on the text and it brought in that interaction. I'll refresh it and go back to interaction. Now, in addition to interacting on that thing itself, you can also separate what the target is. So this button, when I click on it, is going to load in this and replace the placeholder text with the actual text. So interaction target, I click on that, it grabs it from the back end and brings it in. And if I click on here, it makes the same thing, but you notice it doesn't actually have to bring it in from the server anymore because it's already there. We're not going to pull these in every time they're triggered, but just the first time they're triggered, we'll bring it in, and then it's in memory and it can be reused anywhere. Similar behavior with hover. I'm going to come around here. Hovering on this doesn't do anything, but I hover over the button. That was the target for it. Now the hover component comes in, hover on the text. I have immediate, where it brings in it immediately. Not actually sure why you would use this compared to idle, but it's an option. We also have timer. 1, 2, 3. Now we're showing the loading for 1, 2, then we show it in there. You can see the timer component came in after a certain amount of time. And you can create your own. I have this one that will show the placeholder here until the value in this thing is greater than 3. Now we're loading it. We show our loading indicator for 2 seconds, and then we show it. So this also came in developer preview in 17. It was stable in 18. You can use it now for anything you want. And note, for both control flow and deferrable views, because of that @, you'll need to update some tools like Prettier, because otherwise they won't know what to do with that non-standard HTML. And with that, Michelangelo is going to take us into signals, which is going to be the biggest part of this talk. So what are signals? If you were here 2 weeks ago, you heard me talk about them. Again, I'm going to come at them from a different direction now, but signals are a new synchronous reactive primitive, which means they're new for Angular, but you've actually seen behavior similar to this in spreadsheets. So a signal is like a box or a cell that has a value and knows what other values are calculated based on it, and therefore knows how to notify other values, other boxes, other cells that it's been updated. Kind of like in our spreadsheets, we have a number of guests at the top and a cost per guest and a bunch of discounts and taxes and stuff like that to a final calculation at the bottom. And anytime we change our calculation for one of the input signals, input cells, input boxes, it automatically notifies everything below it that you're dirty, you need to be recalculated, and then it will recalculate all of those things based on the new value. That's essentially what we get with signals. It's a box or a cell that has a value that notifies anything that depends on it when its value changes. And you might think, all right, we already have reactive primitives. That's what observables are for. But observables are asynchronous and signals are synchronous, so they solve different problems, and we'll see later how they work together. So why did they do this? Main motivations. One was a simpler declarative execution. Just RxJS pipelines can get pretty gnarly at times. Signals are a simpler way of thinking, simpler way of operating. But the real one is to improve change detection, because it changes how Angular knows when to redraw our templates. The default change detection that we had from the beginning with Angular 2 was based on something called Zones. Zones was a third-party library that would just watch your entire application to know when something changed. So to see an example of this, imagine that we have this application where there's a root component at the top and a couple of child components and grandchildren components, and make it arbitrarily large. It's not just going to be 4 components, but make it as big as you want. And then the user somehow interacts with this child component. With zones, with the default typical way of doing things in Angular, what would happen is with that change, Angular would tell Zone, hey, something had changed. And now Zones is going to do a traversal of your entire application, starting at the root and going through every single component, saying, I know something changed, but I don't know what. I don't know what I need to redraw. Have you changed? Do I need to redraw you? Have you changed? Do I need to redraw you? Have you changed? Every single component asking, have you changed? And do I need to redraw you? Now, fortunately, that traversal is fast. And so you don't really notice it, especially with small applications. But with large enough applications, you start to notice it. And it feels like magic when you first see it, because I've seen people who have kind of rolled their own frameworks be just amazed with Angular that they can make a change here, and then suddenly over here, like the view changes when they press this button, and they didn't have to link anything up, and it feels like magic. And it is, but Zones has some downsides. It's a third-party library, so it adds to the initial bundle. It runs more than strictly necessary because there were corner cases they weren't sure about. And it uses something called monkey patching, which means Zones is actually changing the other JavaScript in your browser in order for it to watch things. And some people have a huge philosophical problem with that. But even if you don't have that problem, there's a technical problem that some things like async await apparently can't be monkey patched, so they have to do a lot of extra work around it. So Zones just isn't a great fit anymore. And it's just going to get worse as more things that aren't monkey patchable come up. The other approach that we've had with change detection from the beginning is called onPush. And with onPush, if the user makes a change at that child, there's still a traversal, but it's just from root to that child. It ignores all the rest of the tree to find out where to make the change. And this is much better performance because it's a much smaller traversal. But there's some downsides to it. One is, since it's not as magic, you have more responsibility to notice that some changes have happened and to use the change detector ref and report them. Also, under this child, you might have this grandchild that isn't using onPush. Maybe it's a third-party library, and it's expecting that the main zone traversal will hit it, but onPush will stop at that child. So the children will never hear about it. So you could have stale data, you could have inconsistencies. Overall, it's still better, but you have to know what the downsides are. With signal-based change detection, the promise is that you can make a change in the child, and then that child is re-rendered. And it's actually better than that. Like individual lines in that child component will be re-rendered. It will know that to the extreme level of detail. Problem is the full implementation isn't here yet. And they're kind of they're working on different factors. It might take a while before we get this as a full thing, but it turns out that zoneless coding works well enough now with onPush that it is not as much of a concern as they had at first. This is not as much of a priority. And it's to the point that the default change detection is no longer default. They're renaming it to eager, and as of 22, onPush is going to be the default. So using onPush with signals will give you very close to this ideal state. All right, so with all that hand waving, let's look at the code. What does it actually look like to use it? So we're coming back to our friend, the sewer component. And again, this component had one and only one bit of state, whether the manhole is open. That's still true, except it's no longer just a plain Boolean. Now we wrap it in signal. So instead of just being false, it's signal false. And we get a writable signal. What this means is that we now have this box that contains that value of false. And the magic is that it knows how to tell things when it has changed. So we want to use this in our template. Now we'll still say if manhole open, but put parentheses on it to grab the value out of that box. and we want to know whether to say close manhole or open manhole on our button. Manhole open with parentheses, get the value out, and we can do the same before. And when we click on it, we can do a set. Get the old value out, invert it, and put it right back in with a set. So we get the same basic behavior as before, but we have a little bit extra code. Another part of the, now this is going to be the same implementation, but showing different APIs. So now on the left, we have the first way I showed you already of signals. And on the right, we have a couple new parts of the API. One is that the text for that button, it's kind of ungainly to do that in the template. Is it possible to do that in the TypeScript? Yeah. We can create a computed signal, a derived signal that will update whenever manhole open changes. So now we are going to create our button text as a signal. Notice it's not a writable signal, but a signal using computed. And we pass into computed a callback that returns what we want that to have a value. So every time button text is to be rendered on the screen, it's going to say, all right, what is the value in manhole open? It's true or false. Based on that, we now know closed or open manhole, and we'll put that on the screen. So we can do derived and computed signals. We can also use a different API for toggling. All right, actually, let's get that on there. Yeah, so the button text with that. Toggling it, we can use update, which is similar to set. But with set, you can give it any value you want. With update, it gives you the old value and you generate the new value based on the old value, which is the perfect thing we want to do for a toggle because it's just going to be the opposite of whatever it was before. So we can say this.manholeopen.update, and it will give you the old value and you can negate it, put it back in, and then we'll get that value. And until very recently, when you wanted to use update, you had to do it in the TypeScript. In the very recent versions, I don't remember if it was 21.1 or 21.2, they've now made it possible to do that update with that callback in the template. It's now possible to use arrow functions in the template. That was not possible before the last couple of months. Now, this isn't to say that update is better than set. They're both good. In this case, update's a great fit. It's not to say that you would always want to use computed instead of defining some of the things like that for the button text in your template, but the computed signal works pretty well. So all of these are valid. They just have different use cases where some of them will fit better than others. And the way the signal is going to work overall, now that we have this with a computed, I'm going to talk about the push-pull semantics of signals. The way it actually works inside is that when you make a change to an input signal, it pushes dirtiness to any of its dependencies. So when the user clicks on that button, it's going to call update. Let's use the one on the right. It's going to call update and change the value in that. And so that box is going to have a new value. But the important thing is that box is also going to know that it is dirty. And then it's going to notify all of the other ones that depend on it, which in this case are button text and the template itself up at this top line, that it's dirty. And by telling the button text that it's dirty, button text now itself is dirty. And so button text is going to tell the template that it's dirty. So now the template is going to know that this specific line and this specific line are both dirty and need to be re-rendered. And so it is going to, Angular is going to ask that template to re-render, and it's going to recalculate this one, which is simple. It's just holding a value in a box to show it, and recalculate this one. So it's going to re-execute this callback, get the value out, change whatever the string is, and put it on the screen. So we're pushing dirtiness and pulling the value. We click the button and it pushes dirtiness down to all of its dependencies, including the template. And then when the template re-renders, the template will say recalculate now. And that combination enables us to have very fast behavior, doing this all glitch-free because otherwise, or without anything like partial calculations, because we're going to pull the value in and it's going to know internally the order of calculations to do. So we get glitch-free, very fast, and internally cached values. So it's not going to have to recalculate again until it's the things it depends on have changed. That is the reason that we went to signals, getting that type of semantics so that we can have that level of change detection is exactly why signals are powerful. But with that computed signal, that I pointed out briefly that it's not a writable signal, but it's just a signal. What if you wanted to be able to do that? What if you wanted to have something that was computed, but that you could call a set or an update on? And we get that from link signal. It's like a computed signal, but instead of saying computed with the callback, it's link signal with the callback. And that means that this link signal value is the first value it gets. But if at any point this function gets called to change the label, well, that it gets overridden. And then if the user clicks the button again, this will be recalculated. And then if they change the label again, like either one, whichever is most recent will win. And there's some other more complicated versions of this that allow you to base your signal value on the old value and have multiple sources and things like that. But this is the basic approach where link signal is just a computed version, a writable version of the computed signal. This was a preview in Angular 19 and it's been stable since 20. Another important part of signals with our API are our queries, inputs, and outputs. So in our components, we often interact either with the template or with a parent. So interacting with the template, we'll use view child or view children to get elements out of the template, or if there's projected content, content child or content children to interact with what is projected in. Those were done through decorators, but now we have functions. If you want to get the element that is EL, now you use view child with parentheses, and now we have a signal that gives us access to that. And you can use that signal in any computed signal you want. Bad guys, previously, we would get that through the decorator. Now, again, it's a signal by using that function. We see this more often with inputs. We could declare that this component needs to be passed a list of bad guys from its parent. And sometimes optionally can be passed a selected ID. Now we'd say input.required bad guy. Input, an optional input would be for the selected ID. So now these are signals. Again, we can then put them on the screen, use them in computed or link signals or whatever. And output was also changed from a decorator to a function, but it's not actually signal-based, but kind of throw it in because the change happened at the same time with the same syntax. But the inputs and the view and content queries are all now inputs. And it's much more powerful, much easier to work with them than the old way of ng on changes and stuff like that. So how does this all work with RxJS? In order to see that, we're going to dig into this example application that Michelangelo had to keep track of his bad guys. So the way this application works is when it initially loaded, it pulled in from the back all of the bad guys in the list. There were 10 of them. And then there's a form control where you can filter that down. So as we type in rat, filters it down to 1. Type in just RA, then we get more matches there. And when we click on an individual one, we select that, highlight the one we selected, and then use that to go make another call to the back end to get more information about that particular bad guy to show in the detail view. Pretty typical behavior that we have with applications. This is what the template looked like. Again, on the left is the RxJS way that we're all familiar with. On the right is signals. On the left, this all works. We're using subjects and async pipes. So when we want to get that full filtered list to put it in, we have a filtered list observable, pipe it through the async pipe. And then depending on your strictness, you might have to use the nullish coalescing to do a backup of the empty array. But that worked for us. To pass the selected ID into the view, that's another observable. We can pass that in. In the bad guy view, again, another observable. Use the async pipe. Yeah, I can highlight those. And all of those worked, but now we're going to change them to signals to get the better change detection. And now instead of needing to use the async pipe to pull the value out of the observable, well, these are all just boxes. We use parentheses. We get our value out. It's easier, and it's done, and it's right there. And the label view will also send to the parent when you click on one of the particular bad guys. So we keep track of which one is selected. Previously, that would have been done with a subject to next it on there. Now it's a writable signal, and we just say set the signal on it. Now it's time to look at the actual TypeScript for this. Again, on the left is the RxJS way, on the right is the signal way. And some of this is going to be identical. In both cases, we're going to have a bad guy loader service that we inject. And in both cases, we're going to have a form control. Then things diverge a little bit. So walking through the RxJS approach, we'll have a subject to keep track of which ID is selected. Initially, there won't be any. It'll be falsy. But then eventually, you can select a particular one, and we'll say, all right, ID number 7 or whatever, and we can use that. To show our filtered list, we're going to build that based on what's in that filter. So when that filter initially starts, it's empty. And so we want to start with that value. And then anytime the user types, we want to use that as the basis to make another call to the backend to get the filtered list. But we don't want it to go too fast. Like if I'm typing really quickly, we don't want to slam the server with our calls. So we'll do bounce time. We'll wait 250 milliseconds, a quarter of a second after the user is done typing before making our call to the backend. But then once the request has settled down, we'll take that, make a call to the backend with a switch map. And it's going to call to the backend. And however long our network lag is going to be on the backend is how long we'll have to wait. We'll get that result in there, process that through our pipe, and it's on our filtered list. Our selected bad guy, what we showed here on the right side, after an ID is selected, that's going to start with that selected ID subject. And every time it has a new value, we're going to switch map on that, make a call to the backend, wait however long our network lag is, and get the full details of that bad guy to populate that table. In order to look in on the signal side, I'm going to zoom in a little bit. So again, the top two lines are the same. We're still going to use a service. We're still going to use a form control. But now our selected ID is going to be a subject, a signal instead of a subject. And there's a bit of a difference here. That subject was just a subject of number, but it was all right that it didn't initially have a value. Subjects can do that. Signals can't. Signals have a value at all times. So if this one initially doesn't have a value, we have to tell it. We have to say you're a number or null. If we haven't given you anything, you're null. We have to be explicit about what all of the different types are. We can't have the falsiness, looseness that we have with an observable. But then when we deal with our filtered list and our selected bad guy, we run into a little bit of a problem. As I've said, signals are synchronous. They don't have a concept of time, but look at how much of this is happening that has a time concept. We have a debouncing. We have making our calls to the back end, which however long that is, and waiting for that, and then getting our results back. Signals can't implicitly do this. So the way that we're going to do this for us is that what we want to end up with a signal, but we have to do observable stuff in the middle. So we're going to start with our observable form control, or reactive form control, and do our observable stuff, the bounce time and the call to the back end and the waiting and all that. And then when we're done, we'll convert that to a signal. So anytime there's a new value from the back end, it'll just be a new value on the signal. Now, again, signals are not comfortable with just not having a value. So if I needed to put this initial value in there, which works as a bad guy array, so that we have an initial value before something comes back. If I didn't put that initial value in here, the type would have to be bad guy array or undefined, and then I'd have to deal with that in the front end. It's easier just to put an initial value that matches the type. Things are actually a little bit worse with the selected bad guy, because in that case, we start with the signal and we end with the signal, but we need to do observable stuff to make the call to the back end and wait and all that. So we need to play this game of starting with a signal, converting it to an observable, doing observable stuff, then converting it back to a signal so that we can put it on the screen. And if this all feels ungainly, you're right. And the good thing is we don't have to do this all anymore. But this is what we were initially given, and this is what's happening behind the scenes. Now we have the resource APIs. So a resource API lets us start with a signal and end with not just a signal, but actually a bunch of signals. And then internally, it does the conversion to RxJS for us. So in this case, this from another component where we look at our allies, and the starting signal we have is the sort order, ascending or descending. We'll pass that starting signal into our resource as a param. And then anytime that changes, it will pass it for us. We'll pass that to the stream and do the calculation, make the call to the back end and do the wait and internally do a switch map and all of those things so that what we get out of at the end is a bunch of signals. We'll have a Boolean. It's actually not a signal, just a Boolean. Do we have a value yet? Yes or no? We'll have a signal with what are the actual results of these? What's the value in here? We'll have a signal of, are we loading right now? We'll have a signal of, is there an error? If so, what is it? And just a general status signal that combines the loading and error and stuff like that. So this is really powerful because we start with a signal, we end with a bunch of useful signals that otherwise we would have to do a lot of lifecycle work to manage, but it just gives it to us and we don't need to manage the conversions between signals and observables. All of that is done internally. The switch map, all of that is done for us. It's really powerful. Now this version is RxJS based. For promises, there's also resource instead of Rx resource that's promise based for fetch. And the interesting thing is this has been around for a while, over a year, but it's still officially experimental. A lot of people are using it, but just know, since it's experimental, they can change things. So like at one point they changed, it used to be source instead of params and something else instead of stream. They changed those names and they don't feel obligated to give any sort of migration. So really, really useful, but just know that the API could change. So what is it like to use these? Well, it makes our life a bit easier. So remember, for the filtered list before, we started with an observable and then converted it to a signal. Now, we're still going to start with an observable, but a lot of that stuff can now be delegated to the resource. The only parts of this that we really need to be done still in the observable before the conversion to a signal is that debounce. So we'll use the initial value to get the first value out instead of start with. We'll debounce on it. That's done in an observable land. And then we hand that to our resource, and the resource makes the call to the back end with the switch map for us. So we'd still have a to signal, but it's wrapping only the initiation information, not the whole behavior. And we get an even better advantage with the selected bad guy. Remember, that was the one where we start with the signal, convert it to an observable to do our switch map, and then convert it to a signal at the end. Well, we don't even need to do that. We start with our selected ID signal, use the params to pass that directly to the streams, and internally it does the switch map for us and just gives us all of those signals at the end. So it's much, much cleaner, much more explicit. How does the template change? Version on the left is our first template with signals. Version on the right, well, for the most part, it's just, instead of saying filtered list with parentheses, it's now filtered list dot value. That's not bad. But even more, oh, and same thing with selected guy, but we actually get a lot more power. We now have the ability to say, all right, do we have a value before showing it? And then bottom, you can see, all right, if we have a value, show the bad guy. Else, if we're loading right now, we can show a loading indicator. Or if there's an error with the call to the back end, we can show whatever the error is. We get a lot of things for free that used to be lifecycle things that we would tend to forget to do. And in addition to Rx resource and resource, there's also HTTP resource, which is a simpler version in some cases. The simplest version is what we see at the top. We have an HTTP GET call that is just the URL. Give it the URL, and it does all the work for us and gives us a whole bunch of signals. There's other versions of this. You can define params and a default value. Like, there's a lot in this API that you can do. But in the simplest version, you're just giving it a callback that returns a string with the API, with the URL endpoint, and you're done. This is newer than the other versions of resource, and it's also still an experiment. Now, a note, all of these things internally use switch maps, which means they should only be used for gets. With switch map, if you make a bunch of calls in succession, they will get canceled and only the last one will survive, which is fine with a get. If you want to just make sure you always are showing the latest version on the screen, that's great. But if you're doing any mutation, delete, put, post, update, then this is a bad choice, because if you want to send in 4 changes at once, it's possible that 3 of those will get canceled and never get executed, and only the last one will, and you'll end up in a weird state. They say they are in the future going to give us a mutation version of the resource, and there are third-party libraries that do it, but we don't have it yet from Angular. Now, you might have been wondering why I said that we still had to use that reactive form. Well, we don't. There's actually a new way, and it makes it even better because we can now have a signal-based form. This is a brand new thing in Angular, a signal-based form. So we don't even need to start with an observable in that first case. So previously, we had our name filter being a new form control, and from that, we grabbed a value every time the value changed in an observable. Well, now we have a new approach. We create our filter value as a signal and wrap that in the new signal form. And on that, we can give it a schema that has a lot of things. In this case, that debounce, which is normally something, it's a time thing. Normally something a signal can't do. But this is a special case that it's really important, so they gave us this hook to do it. This schema is also the place where we would put in validation and a whole bunch of other stuff like that. This is a simple case. But now what we have is, instead of needing to get the observable from that reactive form and convert it to a signal, we're dealing with a filter form that decorates this signal, and then we can just work with that signal. So we have even fewer inner points where we need to deal with observables. How does that change our template? Well, instead of a form control of name filter, now it's a form field of filter form. And that's pretty much it. Now, there's a lot more to talk about with signal forms. This is only the very beginning, but it just shows that by hooking these signal forms in, we can make our lives easier. And this is even newer. This was experimental, introduced in Angular 21. So very new, and it's changing fast, and they're adding stuff to the API. For example, what we call form field now was called field, and that was changed in 21.07. So this is very new. It's bleeding edge, but it's really cool. One more part of the API to talk about is effect. Effect gives us the power to do essentially what we used to do with manual subscriptions, with observables. So imagine we had an observable that had our filter text, and then every time that changed, we wanted to update our query params. In the observable way, we would do it like this, where we would have our subscriptions, and we would subscribe to it, and then have a callback that would give us a value. Every time we have a new value, we could call update query params. With signals, we can have a signal filter text, and then we would use an effect. And an effect will take a callback. That callback doesn't get each value, so it's a different callback than we have with the subscribe. But instead, we use that signal directly in the effect. And now every time filter text gets a new value, this callback is going to be re-executed, and update query params is going to be called. And notice there's a line that we don't need anymore. Previously, with RxJS, when you make a manual subscription, you have to take the responsibility to manually unsubscribe or a memory leak. We don't need to do that in signals, which is nice. So what's the status of signals? It's developer preview in 16, mostly stable in 21, not the resource APIs or forms. Zoneless is now the default, and a lot of things are still to come. Signal-based components and change detection and routing. And besides these, in the last few years, there have been many other improvements. Faster builds with Vite and ES Build, including now testing with vtest. Server-side rendering and incremental hydration. Let lets us have variables in our templates. There's migration schematics to change a lot of these things that I've shown. There's hot module replacement, which means as you're writing your templates, it will automatically redraw in your browser without needing to do a full recompile, which is great. There's a whole lot of AI support. There's a brand new website and a lot more. Just you can see all these release notes and blog posts to get more details. And with that, that is my talk about the Angular Renaissance. The turtles and I thank you for coming. My socials are on the top, and here again is the slides, link to the slides if you want to see it. So thank you. So I see Tayamba in the chat asked my favorite Renaissance feature. I'd say my favorite Renaissance feature is signals. I mean, the other ones are nice. The other ones are definitely make things easier. I haven't used deferrable views much. But having standalone components is great, and the new syntax for control flow is so much better than the old one. But really, signals is just kind of a game changer. It's really changing how we do things. It's really powerful. If you want to go, if you have state management, specifically with our NGRX, there's now signal store with NGRX, which is a completely different approach to it, and it's so powerful. Yeah, like I do almost everything I can in signals now, so that really is my favorite. Someone else asked, what would I advise a team preparing to migrate a legacy Angular project to a newer version? So it depends how legacy. If we're talking Angular JS, the jump from Angular JS to Angular itself is pretty difficult. But let's say we're talking about something like Angular 12. The advice I would take is to go step by step. You know, there's an Angular update site where you can say, I have an application that's at Angular 12, it's of medium complexity, and I use material, I want to go to 13. And you put that in a form, and you click, and it gives you the explicit commands to do and the migrations to run, and you do those. And you do those step by step by step. You don't do like 12 to 21. You do 12 to 13, get that working, commit. 13 to 14, go through all those steps, commit. 14 to 15, on and on and on. Stephen Fluin had an NGConf talk in the last couple of years. I don't remember when exactly, where he did that. He took an application, it might even have started in AngularJS, and he showed each step along the way. I would say that that's a good talk to look at, to just see an example of what's involved at each step. It was a tiny application, of course. Your applications are going to be more complicated, but it was a tiny app that showed just how going from Angular 5 to 6 to 7 to 8 to whatever it was at that point, what it involves and the different things you have to do. Some of the migrations are really simple. Some of them aren't. If you have Angular material, there was a migration, I think it was Angular 14 or 15, I don't remember for sure, where they changed a lot of the internals of Angular material. So like the team I was on at the time, we had done a lot where we were making use of semi-undocumented features and doing CSS targeting of selectors that were internal use only. And so things just didn't work anymore. And it took us a long time to make that conversion. There's others where you run the schematics and you're pretty much done. That's the usual case. I'm not sure if you want more than that, but that's what I have to say immediately. Let's see. Someone asked, apart from a feature being stable, what other factors should one consider before migrating to a newer version? Well, it's interesting, like for the stability, like the team I'm on has not started using signal-based forms at all, but we are all in on the resource APIs, even though those aren't stable. And when they made the change that, I forget exactly what it changed, but I mentioned it earlier that they changed the names of those two properties on the Rx resource. Like we had to manually make those changes. There wasn't a schematic for it. We probably could have created a schematic. We could have used AI to change it, but we weren't as into AI yet. But even though that's officially experimental, it's so much easier than the more explicit way of having to do to signal and to observable everywhere that it's worth it for us. You know, I would actually be excited to use signal-based forms, but the application I'm on doesn't have that many forms, so it's not a driving need right now. But if I had a heavy form-based application, I would jump to signal-based forms even though they are experimental, knowing that you're potentially causing yourselves trouble if they change in the APIs. But I think it's worth it because it's cleaner overall and the mental model is better overall. That's a basic approach I would use. I don't know if there's other thoughts that you had in that question, but that's what comes to mind first.
Okay, thank you. Thank you for that. Yeah, please feel free to ask a question if you have any question. And maybe just to add a comment, I think for us who have been, so I started writing Angular when it was at Angular 8. So it was really great to see that morphing from the likes of ng switch, ngIf, and ng4. And I think the most important thing that people used to mention was for someone who is new, and then they come in and they see something to do with ngIfs and ng4. Yeah, they're seeing something like an if and a for, but they don't really understand what exactly it is. But when with the new control flow syntax, when you had the at if, at else, at for, it's kind of intuitive, because for someone who's coming from a background of JavaScript, it's pretty much easier to just understand, because here maybe there's an if statement, there's a for loop over here. And the thing we usually like to encourage people is like, don't think of it as something like it's too hard, but think of it as like you're writing basic JavaScript, and the only difference is just adding an at sign, an at symbol just before it, and makes it easier for someone to understand. So even for beginners, it's kind of intuitive there. When they get in that code base, it's easier for them to just understand.
Definitely. One thing I would say with the schematics for the control flow, one spot where, or I mentioned, it covers like 99% of the cases. A couple of spots where it doesn't cover it so well. I definitely have seen code where someone could have done an ngIf with an else, but they didn't want to deal with that hassle, and I don't blame them. So they had one line that was an ngIf foo, and then the next line that was an ngIf not foo, which is totally reasonable. But the schematic will convert both of those, and so you'll end up with a if foo whatever, then separately if not foo whatever, and that could have been an else if, or sorry, just an else, and so it won't know, it isn't quite smart enough to see that it can collapse two different ifs into an if else. Not a big deal. It's still so much better than what you had before, but it might be that after you run the schematic, you'll see some spots like that where you can tighten things up, where you just had kind of some weird nesting constructs because you were limited to the ng4 before that. Now that you have if, else if, else if, else available to you, it's just easier to do it. And so you might rearrange a little bit, but it's going to do the hard work for you.
Yeah, thank you. Thank you for that. Anyone else maybe has a question? I think I say thank you. Yeah, thank you as well for also being part of our audience for today. We appreciate you for also taking the time to come and listen to us as well. Yeah. Anyone else maybe has a question? Feel free to drop it in the chat. Maybe if someone is still just typing in the question, maybe Lance, for me, would be like, in terms of the developer experience for you, someone who is a well-seasoned developer, and I'm very sure you started off when it was AngularJS. How would you rate the developer experience from AngularJS to where we are right now at Angular 21?
Yeah, it is so much better. TypeScript is better, and Angular is a lot better. There are just so many concepts that you don't have to worry about as much. Things that are smoother, things like the control flow that just reads easier, things like signals and the resource APIs that do a lot for you. You're right, I did start out with AngularJS, and when I switched into AngularJS, I was coming from Java. And so going into AngularJS pre-TypeScript, I felt like I was living in the Wild West. That's an American metaphor. I don't know if it makes sense for Kenya, but I felt like I was living in a world with no rules and no laws, where I could just type anything I want, and maybe those characters would be the name of a property or method somewhere and it would be executed, and maybe not. Who knew? There was no way to have type safety that I knew of to really see things. Uh, and so for me, coming from a strongly typed language like Java that I'd lived in for 15 or 20 years, it just felt completely uncontrolled. But now with TypeScript and classes um, and Angular's much more type safe approach and very opinionated and thoughtful approach to things, it's so much better than it was, particularly compared to AngularJS. But even compared to the first versions of Angular 2, there's a lot more stuff that is in there that makes sense. I also recommend, especially if you're starting a new project, start it with strict mode on. Some people will turn it off because they don't want to deal with it, but having strict mode, those guardrails are good. Those guardrails are useful. And if you are on a project that doesn't have strict mode on for your TypeScript, work on turning it on. It's going to be painful at times because you're going to have to fix things that you didn't realize were broken. But it's still better to have those things fixed.
Yeah, thank you. Yeah, Tamba says that that Wild West feeling is exactly what I felt when I switched from C# to JS.
Yeah. So does that metaphor make sense at all to Kenyans?
Yeah, yeah, it does.
You see enough American television that you know what.
Yep.
Yeah. So.
Yeah.
All right.
Right. Yeah, I'd like to say a big thank you to Lance for being with us for the past couple of sessions, and we really, really appreciate you taking the time as well for this. I think for most developers here, some of them are just joining in when maybe past Angular 16, so they don't really know the pain that we used to go through back then. But we really appreciate also for you taking the time to take us through that change from where it was before Angular 16 to where we're now at Angular 21. It really, really puts kind of like a perspective in terms of like what we should appreciate as developers, like whereby we have a framework that keeps on changing and improving based on the feedback that we're getting from community. I remember when we were starting off Angular Kenya, we had quite a number of complaints like, the learning curve is too steep. We really need something a bit simpler. I don't know what ng modules are, and I'm happy to see that the feedback we shared with the team keeps on improving the framework itself, and I'm happy also to see that as well.
Yeah, it is a much better framework, and it just keeps improving, and great stuff is coming out. And for the people who showed up or who already knew about the standalone components and some of these things that are older in the talk, I'm sorry if that part was a little boring. Maybe it was a good review, but this talk is interesting because some of the things I talk about are from Angular 14 and 15, and some of the things came out last month. So it's a variety.
All
right. So thank you.
Thank you very much, Lance. Thank you everyone for joining us for this session. Please do be sure to just always subscribe to our channel, because we're always going to put up the next session very soon. Make sure you just turn on notifications whenever that is so. Thank you, and hope that you got to learn something new, got to supplement your knowledge with even more content on this. Appreciate you for also taking the time. Thank you, Lance, and thank you to everyone. I wish you all a great evening.
Thank you.